Good morning, everybody. How's everyone doing? Welcome back to our daily pre-cal videos. Today we're going to be talking about, or continue talking about sine and cosine functions, and we're going to look at phase shift. And my dogs are getting a little upset behind me. So, with the phase shift, so what we're going to describe in phase shift as is a phase shift of a sine and cosine function is the difference between the horizontal position of a function and that of an otherwise similar sine or cosine function. So, to help you kind of visualize what this essentially means is let's look at an example. Let's look at our first example right here. F of x of sine x, g of x of sine x minus pi over 2. So as you can tell, sine x is just our typical parent function for that, or our fx is our typical parent function for sine x. So we have a line, or we have our wave that will continue on forever. Okay. Now for g of x, sine of x minus pi over 2, you can see its starting point is actually at pi over 2. Okay, so it shifts over this pi over 2 and it continues on right here. Now in reality it does also come, so let's finish that right here, okay, and it continues on as well as go on forever, as well as this thing does, kind of like this. Okay, so these do go on forever and they keep repeating that process, but we're just kind of looking at one period, how that shifts over pi over 2 or whatever that function is. So how do we kind of come up about that number? It's not just dealing with this right here. So what we're going to see is we're going to go back to that basic, that sine and cosine function that we've been using so far. Y is equal to a times sine of x, all, or sine of bx plus c, all plus d, and y is equal to a times cosine of bx plus c, all plus d. Okay, so we're going to use those equations again, and we're going to find the phase shift. So the phase shift actually deals with two of those variables, c and b. Okay, for c and b. So what you do is you take the negative of c over the absolute value of b. Once again, you're always going to take the absolute value of b because you don't care whether it's negative or positive. You always just take the absolute value, which turns out to be a positive number every single time. So that's what that essentially means. You're going to set those two over, or you're going to set them over each other, and you'll get your phase shift. Okay. So for us, let's kind of just do a problem to kind of see what that looks like. So down here we have state the amplitude, the period, the frequency, and the phase shift of f of x is equal to cosine 2x minus pi. Okay, so for the first one, amplitude, that's the easiest function. Okay, remember amplitude is always going to be whatever's in front of the cosine, whatever you multiply to it. Since there's nothing there, okay, the a value is simply equal to 1. Okay, so we'll say amplitude is equal to 1. So that essentially means that our maxes and our mins will always be this one value right here. Okay. Next, the period. Okay, so remember the period is going to equal to, so p is equal to 2 pi over the absolute value of b. Okay, so our b term, this is a, this is b, this is c, and we don't have a d. So our b term is actually going to be 2. So we're going to plug that into this equation. 2 pi over the absolute value of 2. The absolute value of 2 is just 2. So 2 pi over 2 is just going to give me pi. So our period ends up being equal to pi. Okay. Now for frequency, remember you have two different versions of frequency. Okay. So for frequency, we can say that's 1 over period, or we can say absolute value b over 2 pi. Now for us, once you have your period, okay, you don't need to do anything else other than that. Just take it and flip it. Okay, so since this is technically pi, we can say the frequency is equal to this but flipped. So we can say instead of being pi over 1, we can say this equal to 1 over pi. Okay, so now we have the frequency. And lastly, the phase shift. So the phase shift, we're going to use our equation. Okay, so we're going to take our c value, negative pi over, and we're going to take our b value, absolute value of 2. Once again, the absolute value of 2 is just 2, so we have negative pi over 2. So we have our phase shift. So we're going to say a phase shift is equal to negative pi over 2. And actually, I'm sorry about that. our C is negative pi, right? It's negative. So if we have negative of a negative, right, those actually become positive. So it's actually going to be a positive pi over 2. I'm not sorry I didn't mention that earlier. Okay, so that's all a phase shift is. Okay, that's all. That's how we combine them. As you can tell, we'll be combining these every single time, and you're just gonna. It's just a simple process of identifying an amplitude, a period, a frequency, and now we're identifying a phase shift as well. Okay, so that's it for today's lesson. Tomorrow we'll be going over a little more something else. Okay, I hope you're having a great time, and peace.